and use a spotter. Lastly, ensure that the step-off point reaches 3 feet above where you're climbing to, and do not use the top 2 steps. All right, getting into the presentation here, the first thing I want to speak to you about is our service capabilities. We offer on-site service for both Moino pumps and Kimminer agitators. We offer things like turnkey installation, service contracts for both maintenance and reliability, rebuilding and repairing existing equipment, both on and off site, supervision of installation, and startup support. Also, I want to mention, if you have any questions while I go through this presentation, feel free to stop me at the end of a slide. Okay, the next thing I'm speaking about is sound analysis. Now I'm jumping from our service capabilities, which I am briefly speaking about, to a solution for a problem a customer might have. Now, if you remember when COVID hit, a lot of customers were reaching out to us and asking, to send a video in or saying, what is this sound? My gearbox sounds bad. And no one could travel at that time and things were a problem. So during this difficult portion for us all, we came up with a solution called sound analysis. What sound analysis is the isolation of a sound file from a video obtained by a customer or client who's having a problem or a concern with their piece of equipment. Now, we generate a couple different things from that sound file. We use mathematical numerical analysis, or MATLAB software, to analyze the sound file. We generate a couple different plots that help us to analyze that sound file and tell us what's going on. Specifically here on the left, you see a spectrogram. Now, what a spectrogram is time on the x-axis, frequency on the y-axis, and then we use a color plot to differentiate between the amplitude at specific frequencies. Now, if you know a little bit about gearboxes, we have gears and bearings within them. And I'm specifically speaking to a gearbox in this example. Bearings make discrete or exact frequencies for specific types of failures within the bearing, and so do the gears. This allows us that when we see specific lines at frequencies to tell a customer what is failing. Now, one thing you might be wondering, or you might be thinking about, is some of our equipment runs at really low speeds. We can also tell in the time domain, or in pulsing over time, if they have a failure at a really low speed. We found this to be really successful for telling a customer quickly what could be failing and helping them quickly get a solution. The goal here is when they see something that sounds bad, to tell them what they need to do and quickly get a plan of action going for them. All right, next I'm going to speak a little bit about our on-site capabilities. Now, this is stepping away from a quick solution and going to something that's more in-depth. Sometimes a problem can't be simply answered by analyzing a sound file, and because of that, we have a lot of capabilities to quickly answer or to quickly get to site and mobilize and tell people what could be going on. Now, this right here is an example of modal analysis. What modal analysis entails is impact testing, or testing for natural frequencies. We have calibrated equipment to impact a piece of equipment and see what the natural frequency is. We also can do an operational deflection shape. Now, that's what's animated or going to be shown here shortly. An operational deflection shape is real-time operation of the equipment with data gathered at many points. We take all this data and we can then animate it and show people what is going on at specific frequencies or throughout the whole broad spectrum of operation. I'm going to pause here quickly and show you an animation, or what it actually looks like. So here you see an agitator that's acting as a rigid body and the beam structure deflecting. I'll play that one more time. Now, it's important to know that we have to be cautious of how we look at this, and is this bad or is this good? And that's in the analysis of this. Now, another thing that I want to show you is an example of why it's important to look at your data. Now, this is actually good data, but what we found as we were working through and testing this piece of equipment was bolts were actually working loose. So In summary here, what I want to say is it's also important to analyze your data before we leave. Oftentimes when we're at site, we'll spend a day or two gathering data and reviewing prior to leaving to ensure that we have a correct answer to what the customer's problem is, because the goal here is always to provide a correct answer to the customer. This type of data can be given to engineering firms, our own internal engineering team, and used to change or validate structures that our agitators are mounted on. Okay, next here, I'm going to speak about what I like to call a comprehensive analysis. Now, what this is using many different departments within NOV, or specifically in Chemoneer in this instance, and validating what we suspect or what we see on site. Here, we used an orbital analysis of the output of the gearbox I'm sorry, it's not the output of the gearbox, at the bearing housing of the gearbox to determine what was going on. We were unsure of how the vessel was reacting as well. So we did a computational fluid dynamic analysis, or CFD, of the vessel that also told us force in the axial direction and what was going on inside of the vessel. Lastly, we validated what we suspected to be going on inside of the vessel with an orbital analysis. Now, what that is using proximity probes to monitor how the shaft is moving and validating that in real time. Okay, so next I'm going to speak a little bit about performance analysis. This is an on-site service that we offer. Oftentimes you'll see in bid specs or things like that, the need to validate a pump's performance. What we've been offering and have the capability of doing is a true on-site performance analysis of a pump. We can validate against theoretical curves and tell the customer that indeed their pump is operating as intended. This is excellent to do during commissioning or startup. And lastly, we can also gather vibration and sound data for validation and acceptance as well. Okay, so I've kind of talked a little bit about some of our field and quick solutions that we offer. Now I'm going to speak a little bit about digitalization. What digitalization is, or what we term that, it's an online suite of software and sensors that are mounted on the equipment, and this can be any type of equipment too, I should mention, that gathers data real time, 24/7, 365. So this isn't something that requires a site visit other than to install and to ensure operation. We can monitor the customer's equipment and tell them what's going on at any given moment. They have access to this data anytime they'd like to log on and check on it. Also, they can set alarms and notifications via text and or email. Okay, and here's an example of a really complex installation of one of these systems. It's in a C1D2 environment, which is high dust. The system is installed on top of an agitator in a really tight corridor. The installation on 4 of these took approximately a day and a half. NOV, or my team, also ensured that they were operational prior to leaving and the customer had good data flowing in. And lastly, I want to mention that these systems can be installed on really any type of rotating equipment and in any type of environment. Here you see an example of installing this on an air handler. There was a problem unit for the customer. They were having multiple bearing failures, and what this allowed us to do was monitor bearing temperature and vibration at the bearings and tell them if they were having any failures. All right, that concludes my portion of the presentation. Any questions?
Hi, Darin. There were a couple questions from the audience. That first one would be, where can we send some inquiries for sound or on-site analysis?
Okay, if you wouldn't mind, let's share our industrial email on the comments section here. That'd be a great place to reach out, and they will get me in touch with you.
The next question was, does sound analysis prove to be an effective diagnostic tool?
Certainly, yeah. So we've been tracking, or I've tracked as we've been doing this. I'll be the first to admit I was a skeptic when I first looked into doing this. We've averaged about a 96 to 97% success rate on diagnosing at least what the area of the gearbox or piece of equipment is causing the sound.
And then the last question from the audience that we received so far, can anyone perform these types of analysis?
So the short answer is yes, anyone could gather the data. The real difficulty in doing this is actually analyzing the data and letting the data speak, so to speak. That's where it really can be tricky sometimes.
One other question just came through. Do the instruments have to be hardwired, or could they also work via a wireless system?
Yeah, so there are options both ways there. There are wireless options. The issue you run into that, especially for long-term installation, can be battery life. Um, with hardwired equipment, obviously you have power continuously going to the sensors. So there's advantages and disadvantages to both.
Hey, Darin, when you talk about some of the data you analyze, especially on some vibration stuff, you said that anybody can analyze it, but it takes, somebody who knows what they're looking at to kind of interpret it. Can you kind of go in details about that?
Yeah, certainly. So one thing that we do is with myself, I'm a Cat 3 vibration analyst. I've been doing this since about 2009. It takes some time. You might have heard me say earlier, let the data talk. That's one of the tricks. You've got to learn how to let it tell you what's going on. You can't make any assumptions. Gathering the data, you can get gigabytes of data in a very short amount of time when you're doing an on-site analysis. And knowing where to pour through that, when to stop and take a look at something is really the key. And that's just comes in training and time in doing this.
For that sound analysis, can you indicate if it's a gear or a bearing, or how does that work?
Yeah, so yeah, we can usually tell pretty quickly. For all our equipment, we have tables of all the fundamental frequencies of both gears and bearings. And by using that, we can relate back to the frequencies that we see what's failing.
Awesome. I don't think there's any more questions. If a question pops up in the future, please reach out to us. You can reach us through our industrial mailbox. You reach us through our sales reps or distributors. Um, please use our websites, nov.com, cheminator.com, or moino.com. We will continue to do this aftermarket and service campaign. We did an NOV live a month ago, and we are continuous to do training videos of how to break down a pump, how to install an agitator. So we got some pretty cool content coming your way. With that being said, if there's no more questions, thank you everybody for taking your time to doing our webinar series. Like I said, if you have any more questions, please reach out to us, reach out to me. We'll give you whatever you need. All right, thank you very much. Have a great day.
Thanks, everybody.